back again. Myself Malin, I'm a mechanical engineer. So today I'm going to explain flat leaching process from starting to until leaching from solution from gold solution to until barren solution. So I would like to introduce Henry. He's a plant metallurgist. So he's going to take through us to explain all the process.
Okay, this is Henry. I'm going to take you to the plant, the fat leaching process, how we do it, how we recover gold using fat leaching.
Like we explained last video, so those are the animal plant. Then this is our training part. So this is where we collect all the plants. This is a sand coat and that is a slime. This is slime pond, which is finer particles. And there is a third one also is there, that is collect water. So this is the slime pond which we are going to move from with excavator to from to the surface.
So from here, this is our drying place. When we are drying, we separate the cells and the slime. So first this process is the cells. Yeah. This cells. From that side are the slimes. So we separate them so that during our leaching or when we load them, we first load the cells first, then slimes. We load one quarter, then save 3 quarters, so that there will be enough flow rate throughout the leaching process.
Vat leaching, the reason why we try the sample because vat leaching is a gravity leaching process because we don't have any agitators to agitate for our work. So that is why we use to dry to accelerate our oxygen to sip our percolate our solution.
Okay.
So this is our leaching tank. The capacity of this one is 50 tons. So the measurements for what we designed this one is for 50 tons. The radius of this tank is 6 meters by height is 1.7 meters. So that to the capacitor, when we calculate with a specific gravity for our tank, it is the capacitor of this tank is 50 tons. So yes. We have 4 tanks here, which is 200 ton capacity, cycle ton. So we can, with our capacity now, we can able to reach 200 tons, 4 by 50 tons. Okay. So yeah, the process Mr. Henry going to take through, then I can take it.
Okay. So what happens from the blanket, we will load our 50 ton tank. So first load the same, then go to the slimes. So after we load using a loader. Then after loading, we then go and mix the chemicals to the barren tank. The proportion for our chemicals is 1 kg to 1 ton of ore. So for the 2 tons of ore, we will put 50 kg of cyanide, then 25 kg of caustic soda for the pH control. Then we also put hydrogen peroxide. Hydrogen peroxide is important for the leaching process because it provides oxygen for the process. So we mix those chemicals in the barren tank. That is the return tank where from the carbon box the tail solution goes to. Then we mix our solution. Then when we have the uniform concentration and the right pH, we then transfer that solution to the vat leach through that pipe. Then we can fill the tank. And normally when we are leaching, we make sure that our sands are dry and the slimes are dry for us to make our process very effective.
After we drying sample sands, so that is our drying sands. If you check that one, that is our drying sands, and that is the slimes, that is the drying sand. After we dry sand, we are going to collect everything to put it here. Before we put, we need to make a filtration bed to filter that leaching solution. We did, we put a brick layer down flow, then we can put a Hassan sacks, or we used to call jute bags or Hassan sacks on top. Then we can put a reverse and at least a 100 millimeter, so that to seep and percolate enough filtration. Then after on top we are going to put a wooden sticks. The reason why we put wooden sticks, when we do excavation, we know the reference. That is where we are going to stop. Unless we keep on digging, then we are going to damage our concrete tank. So then we are going to put a provision for this is a breather to accelerate our oxygen flow inside, and we put a provision 2 oxygen vents for the breathing solution. So we have a delivery valve which is downside. You can't able to see now. So that is going to from bottom is going to collect to clarify a tank. So this is a feeding water which is from barren tank. So I am going to explain later. So this is what we have for the tank. So we made a provision for some breather to accelerate to seeping our percolation capacity. So this is we are going to put a sample. When we loading, before loading we used to call that is a head sample and tail sample. When we taking before loading, we take each and every either loader bucket or shovels and whatever, even the wheelbarrows, we take a sample for us to know what is the capacity, what is the gold in it over 50 tons. So that is called as a head grade. Then after we leaching, we can take from the solid waste, from solid waste. For example, if it is 1, after leaching we can test again for the solid waste, because on this leaching tank, as what we observe in our plant here, we used to recover between 70 to 75% of gold from wet leaching tank. So this is just a cost-effective and economic leaching process to leach the gold. So that's why we used to increase by between 1.5 to 2 to leach our gold. So that's why we used to for 1 ton we used to mix 1.5 kg between even sometimes 2 kg if it is a high grade, because high grade need more cyanide to leach, continue leaching. So that is how we mixing our chemicals. And also caustic soda. Caustic soda, if it is 1 ton, if it is 1 kg of cyanide, we are going to mix half kg of caustic soda to leach our wood. So that is why from whenever mix the caustic soda, we can get between 10.5 to 11 pH. Okay. Then after we mix our chemicals, we can mix into here. Then we can start leaching. So we are going to mix hydrogen peroxide also for mostly that is based on the purpose of hydrogen peroxide to accelerate oxygen in terms of leaching. So to create more oxygen. Sometimes we use compressors also to blow and even to percolate our water, cyanide solutions. We are going to use lead nitrate. The purpose of lead nitrate to eliminate other elements from the gold is like a copper, some iron, some unnecessary metals, because our carbon is going to it won't affect in terms of leaching, but our carbon is going to pregnate the solution very fast. So that we remove the carbon. Whenever mix the caustic soda, we can get between 10.5 to 11 pH. Okay. Then after we mix our chemicals, we can mix into here. Then we can start leaching. we are going to mix hydrogen peroxide also for mostly that is based on the purpose of hydrogen peroxide to accelerate oxygen in terms of leaching. So to create more oxygen. Sometimes we use compressors also to blow and even to percolate our water, our cyanide solutions, our gold and cyanide solutions.
When we mix in the Barrington, and for the oxides ore, we put between half a kg to 1 kg in the Barrington, also for speeding up our leaching process to eliminate some of the elements that may hinder to our process.
This is a clarifier. This purpose of this clarifier to collect all our solutions from the leaching tanks to collect here, because if you can check there's an outlet here. From the tank outlet we are going to be connected here for each tank, number 1, number 2, number 3, number 4. So we are going to collect this outlets here. So we are going to open small, very small flow rate to pass through our carbon. So this is a clarifier. There is a filter bed here. It is having 2 compartments, which is filter bed and also pure water here. So on here there is a filter bed, same procedure what I explained for the leaching tank. There is a bricks down, 1 brick layer, and also there is a Hassan 6 on top. Then we put a river sand for filtration to avoid slimes, some other contents, sludge and salts to pass through the carbon. So that is the purpose of this clarifier. Then these are the pilot buckets. Every tank before we do the leaching, and even while we are leaching.
Let's go.
Yeah, this is the pilot buckets. Like pilot buckets is almost close to equal to what we are leaching for the 50 tons. Then we can take a sample, we can collect here, we can mix whatever our concentration, the ratios, the chemicals, then to get our maximize gold. So this is a pilot bucket. We put some solution, then we can soak the solution. I forgot to explain those times soaking period. So the soaking period, what we observed here within our team, for the oxide ores, we are going to soak 24 hours. But for this is a sulfide ores, so we are using between 48 to 72 hours to maximize leaching soaking period. So that is what we did before we do leaching. We did pilot buckets to boost our confidence, how much solution, what is the chemicals, and what is the flow rate we are going to do that. Then we can drill here. On this one, what we did, we took 10 kg of sand for the small bucket. Then we are leaching just a replica of same 50 tons leaching tank. So we put a cyanide solution, whatever, everything, our all reagents. Then we open a leaching vent outlet here. Situate here, outlet here. Then there is the same process of leaching tank, and this is a cyanide reagents and everything is there. So based on that, we can able to leach to maximize our leaching process. And this is a 100 kg. We put a 100 kg pilot bucket for us to know for the different characteristics of our ores.
On the clarifier, that's where we take our solutions for the lab. But before we took the solution samples, we first measure the flow rate first. Then we take the solution from this. Then we go to the AS machine and analyze the solution, the gold content that has been leached. Then from that we can measure, we can calculate the total gold that we have recovered that day using the flow rates. We can calculate by multiplying the flow rates, multiplied over a period of time, multiplied by the gold assay from the lab.
Same solution, we are going to test pH, what is the pH value, and we are going to test cyanide concentration, and also the flow rate here, which is we can take some small container, we can put a stopwatch, we can able to calculate that, and also the gold, total gold in it, with using either if we have in-house lab or external lab, we can use to know the gold, how much gold in it in a day or particular period. Either two processes, either we can do a traditional method which is color test, and either color test is a white color, light gray, or black color. If it is a black color, too much gold, which is some higher gold is there. If it is a gray color, some little medium level. If it is a clear, which means our gold content in our leaching is nothing. So that is what we used to do if we don't have our lab. So if you have a lab, we just go to use a analysis method which I explained in fire assay method. So it's just a simple method if we have a lab. If you don't have a lab, no problem. We can do color test to know whether our tanks still have gold or not. From here. If you can see from here, water is seeping and percolating through the sand, then it's getting here clear water. If it is becoming a gold color, but don't think this is a gold. Gold you can't catch in here. We are going to catch through the carbon. We put a outlet valves, which is a pregnant solution, is going through the pipes and going to the carbon room. This is a carbon room, which is used to call even a strong room, because we build with a concrete, because anti-theft and what this and that. So we put a concrete. This is a 4 meter by 4 meter carbon room. So then our outlet valves is going to the carbon box. So this is from clarifier outlet. It is coming to inlet for the carbon box. This is a carbon box, which is a 2.5 meter by 0.65. So it is having 4 columns, each column having 65 kg. We designed this one as a 250 kg capacity of carbon. So 250 kg, we are going to catch between 1 kg to 1.5 kg. Okay. So that is what we designed for this carbon box. So this is a capacity of 250 kg. You can check, if you can check this one, there is a water coming flow here. We put a provision. This is a separating. Yeah, if you check this column, there's a number. I'm going to explain from starting. You put a provision for this one, a filter. There's a separating from carbon to water. So we put a small gap from downside. We put water can seep through from down to upside. So then what we did for here, same filtration way. We put a bricks downside, then we put a Hassan sacks, then we put a screen which not penetrating through the carbon down, completely down. So this is what we put here. The water coming from through downside pregnant solution, then it can filter number 1, number 2, number 3, then number 4. Then it is going to outlet here. It is going to outlet here, which can almost barren. So from pregnant solution to barren solution. Activated carbon. So this carbon purpose is in a gold leaching process. Any leaching process, either CIP, this is wet leaching process, either CIP, CIL or CIP, we use the carbon, same carbon to catch gold, because only carbon can catch the gold, rest of we can't catch. Carbon it can catch even copper, gold, even silver also. So but our main metal here is gold, so that is why we use carbon here to activated carbon to do for the carbon catching code. So the activity is 95 to 99% this one, because this is fresh.
Yes. Okay, so after the elution process, or after we've tested our carbon and so that the activity is below 80%, we then take the 250 kgs carbon, then do the acid wash. For the carbon acid wash, we'll be trying to remove some of the carbonates and some of the impurities that might have been caged, that may have been caught during this carbon absorption process. So for the carbon activity test, we take carbon hydrochloric acid and make sure we achieve a percentage of 4% carbon 4% hydrochloric acid. Then we soak that carbon for 24 hours. Then after soaking, then wash with clean water. Then after that, we're going to take a sample and analyze for the carbon activity. If the activity is above 80%, we then take our carbon and put it back onto our carbon columns, and the leaching process goes.
Carbon leaching process. Our carbon outlet, carbon box outlet is this is called a barrel tank or a return tank. Where any word we can use to call. So the capacity of this one is 100,000 liter. So the capacity of this one is 100,000 liter to hold the water, our carbon, sorry, our cyanide solution or leaching solutions here. That is where this is the outlet from the carbon. It is return water to come in here. Then same water we are going to return back our leaching process, because this water is barren, which is nothing in the carbon. That is every time we are going to test through this solution whether our carbon is catching or not. So from here we are going to pump back to return back to the leaching tanks. If you check there, that is where that saga bag we are going to put in our reagents, cyanide, caustic soda. So we are going to put in the chemicals into that. Then that is having some little holes. We are going to mix reagent all right round to our return tank, so that to mix our reagent properly. So we don't want any our reagent must be on top or down one side. So that is why we mix all over with the right round with using that saga. This is where we can use our mixing chemical. Some guys they are going to mix directly to the tank, which is a custom leaching process. But this is our in-house, so we are going to mix our reagents here to get effective production, and also after leaching that from through the carbon, we still have some cyanide concentration to add some reagents.
So this is our chemical room where we store our chemical reagents. So this is the cyanide, 50 kg cyanide, and this is the caustic soda flakes. These are chemical reagents, and this 30 liter is that of hydrogen peroxide together with this one, and this is our scale. This is our balancing scale, which is 150 kgs. Where sometimes when we want to maintain our concentration, we measure the weight of our cyanide or caustic, then we put to the barrel tank and transfer to the vacuum tank. Then in this box, it contains our
glasswares.
Yeah, our glasswares for the color test that has been explained before. So We do our color test sometimes when we want to confirm. Okay, this is our hydrated lime that that has been explained before, and this is our hydrochloric acid for our carbon acid wash, and this is the lead nitrate that we add also to improve our leaching processes.
Solid waste disposal dump. Okay, so now after we leaching all our process in our tank, we are going to offload our sands, then we are going to dump here. So this dump still having gold, because as I discussed before, we still have between 30 to 25% of gold in it here. So in this one we are going to reserve this all dump for a CIP or CIL in future. The procedure for the disposing our solid waste, before we dump this one, we are going to put a polythene or a plastic paper, polythene plastic down. Then we are going to add according to when we increase the dump size, because the purpose of polythene paper to avoid seeping some chemicals or some reagents seeping through the ground, and also to affect the environment. That is why we put a provision for this one. Then we put our plastics here, and we made a trench around. Then same trench, and we put a collective place, which is some pond is there. There's some pond is there. In even that pond, we put already some plastic paper. It is covered. You can't see that. It is covered inside because the rains it wash off. There is all it is poly coated, because we don't want to destroy our environment. So that is why we put a provision for all polythene plastics to avoid contamination to the soil, pollution also. Yeah. So this is what we explain our wet leaching process, friends. So on the leaching process, we used to cover from almost close to 75% of gold, which is okay for the small and medium scale miners. So thank you very much.
Thank you.
Thank you very much to supporting us. Yeah, thank you.